Hey guys, it's been a while. So I just want to show some variables, like changing the output voltage on this one. Is what I'm going to concentrate on in this video. And still flipping the coils like I was doing in the previous videos. You should go check out like the last 3 videos or so that I've posted. It's about this. Just reversing a coil and what it does. But start by showing the meters, what's going on with them. So there's the output voltage, 60.61. That's these 3 batteries right here. They're all hooked up right there. Here's the input voltage, this battery right here. That's the scope shot. Same place as always on the output of the driver circuit, going to the coils. Positive, negative right there. Right now all the coils are in series and working together. That meter's monitoring the frequency and the voltage of that coil right there, which is not doing anything. That's all it's there for, is just to monitor the speed type of thing. So I just want to show these two. They're identical. They're in the same setting. 10 millivolts for 10 milliamps setting. They're identical meters. One's a little bit different batch, I guess. It picks up a little bit more static. That's what you're seeing there. It's not hooked up right now, but it's on, and everything is zeroed out, which you can see right here. Lines are centered there, and here's the channel information. Probe time 1 DC for channel 2. See channel 2 up there. Channel 1, same. They're identical. Everything's set exactly the same. So now I'm just gonna hook them up. That's channel 2, the input right now, and here's channel. I'll get it in one hand. Channel 1, the output there, hooked up now. So that's with the motor working all together. All the coils are together. 60.61 volts on the output. I'll just do a quick measurement here. The motor is almost to where it's still speeding up, but it's really slowly speeding up. You can see the voltage on that coil still going up, but it'll probably do that for another half an hour or so. Let's do the bottom output first. So we're looking at 21 millivolts. That's 210 milliamp pulses at 60.61 volts on the output, and the input is 370 milliamps at 13.26. So you can do that math. You can see we're getting way more on the output with everything still working together. So let's get you guys onto the tripod. I'll switch that coil around. And then after this, I'm going to show you what happens when I hook the output up to 15 volts on the output. And the input is 13 volts. Get on the tripod and I'll flip that coil around. Flip the same coil as the previous video. It's going to be this one right here. All I'm doing is I'm going to take these two wires and reverse them. Put this one here and this one here. That's all I'm gonna do. So I'll do that now while it's running. I haven't done this one yet. Haven't did any of this stuff with the different voltages. Should reverse itself at this voltage. Oops. I don't know if I might have forgot which ones go where here already. See if it's, yeah, it's trying to stop. Next videos I'll be concentrating on the frequencies of the driver circuit, I think, if I have time to do that. So now it should reverse itself. And through this whole video I'm not going to be changing any orientation of the coils or the timing. That all effect. Stopping. Here's the scope. See if it'll reverse itself. No, not at this voltage, it didn't. Let's get it going. See, every voltage on the output makes a difference. It's kind of a sweet spot for the rotor to do that, but it's still running in reverse now though. And it'll pick up its speed. If I was to put it back to just these two batteries, it would have reversed itself like in the previous videos. But here's the outputs now. Input and output. Input's the blue. It's going to be a bit of a longer video, but I'm going to pause it and I'll come back when the rotor's up to speed, and then we'll do a quick measurement. Then I'll end up putting the output onto this battery here. It's just over 15 volts, I think, 4 cells in series. And then I'll show you what happens when I do that. But first of all, I'll let this one speed up so I can get the input and output measurements. And I'll be back. Okay, I think it's pretty close to where it's gonna get. It's been there for a few minutes now. As the output voltage goes up, the rotor goes way slower. Both when the coils are working together and also when one is reversed. So do these measurements. Output on the input is 540 milliamps pulses at the highest point right here. Now we'll go to the output. Let's just go at 280. 280 milliamps. So you only times those voltages. Here's the output, 60.62 now. And that's the input, 13.26. And there's a scope shot. Speed of the rotor. Okay, so what I'm going to do now is I'm going to pause the video, but I'm going to put this coil back the way it was, so they're all working together. And I'm going to hook this battery up to the output, and it'll only be 15 volts or so on the output. I'll measure that too. So I'm going to pause the video now, and I'll be back when that's done. Okay, it should all be hooked up here now. There's 15.73 on the output. I'll just use these alligator leads to connect there and there. There's the diode. So let's start it up. I'm not sure. It goes this way. So that's with the 13.25 going in there now. There's the scope, input and output. Blue's the input. Zero. Not quite. Just zeroing it. Blue one out. There. Zeroed out now. Hook it back up. Zero. Yeah, there, it's pretty close where it needs to be there. So I'm just gonna let it speed up and I'll be back. Here's the scope shot. See, we're just over 2 volts higher on the output than what's on the input here now. There's the currents. So I'll be back and I'll take readings when it's full speed. It's sped up here pretty good. It's still going up. There's the voltage. I haven't changed that coil around yet. I'll do that right away after these measurements. Pause this. So this is at 15.73 volts on the output. Looking at 290 milliamps. Conservatively. Check the other one. The input now. So it's 290 on the output, and we're looking at 430 on the input. So I don't think we're over unity here on this setting. $430, and what was the other one here? 2. Yeah, not even close to, even though we're a little higher voltage, I don't think it's even close to what it would be for over unity. Now I'm gonna just switch this coil around. Same as what I was doing before. Same coil. Reverse it now. You'll see completely different effects. We're at 171 hertz right now, climbing slowly. So that one coil's reversed now, so I've tightened the screws, and you see something different. Everything's the same, timing's the same. The only thing I've changed is the output voltage. It's lower now. We were at 171 hertz before I did that. There's the frequency on the top, 163 and climbing again. It's speeding up, and it never changed directions. It's still going the same speed, or same direction, I mean. But now look at these readings here now. Yellow is the output, so we're there now. I'm gonna start with that measurement. So conservatively, it's 480 milliamps. It's 48 millivolts there. And do the input now. Oops. $660 milliamps on the input. So you can see you don't get over unity when you're trying to do it like this. The rotor's still speeding up, it didn't change direction. The key to this is the high voltage on the output spike, which with this north-south configuration, it's what overcomes the with that one coil being reversed with that high voltage reverse back spike. It allows this coil to work in reverse, like it overpowers the other three, and that's what makes it work the way it does with those results. A Bedini motor won't do this. Not with the monopole arrangement. So right now what's happening is this one coil is fighting the other three, but it's not able to overpower them with the back spike because the back spike voltage is too low. When you reverse one coil with the high voltage on the output, it's able to reverse the rotor with the back spike power and use that back spike. There was nothing was changed except for the output voltage. And we're going faster now than when we changed it. I just wanted to show that anyways. It's some different. Some people might not realize that if they're trying to do this type of experiment and you find out it's not working for you, you go to adjust some of your voltages. Timing is also key, and coil orientation is very important too. So but anyways, long enough video. When I get more time, I'll work with the frequencies on the driver circuit, show some of that, how it affects things too. But thanks for watching, guys.